Welcome to science, to sleep by. Tonight, let's slow down together. The world outside may feel restless, full of noise and rush, but the universe above us moves on a gentler timescale. Out there, across the vast sky, stars live so quiet and steady that they make even our longest days seem like passing moments. This is a story not of explosions or chaos, but of calm persistence, the quiet life of a star. So, settle in, breathe deeply, and let's drift together through the soft rhythm of cosmic time. When we think of stars, the first images that come to mind are often dramatic ones. We imagine them as fiery furnaces, raging with unimaginable energy, bursting into life or collapsing in violent deaths. Yet if you take a step back and look not just at the sudden flashes, but at the whole arc of a star's existence, you begin to see something very different. A star, for most of its life, is quiet. It does not rush. It does not falter. It simply shines, steadily and gently, across stretches of time that our human minds can hardly begin to grasp. This is what makes the life of a star so unique. It is not about the rare fireworks we sometimes catch in the cosmos. It is about the long, serene glow that continues day after day, century after century, for billions upon billions of years. To understand this kind of quiet, it helps to first place ourselves in the context of time. Human life feels long to us. 70 or 80 years can seem like an entire era. A few centuries, the distance from the founding of a nation to today, feels monumental. But a star does not measure time the way we do. A star can spend millions of years just gathering itself together before its light even begins to shine. Once it is fully born, it may live in a balanced state for billions of years, burning calmly and consistently. To put that into perspective, the sun above us has already been shining steadily for about 4.5 billion years, and it is only halfway through its quiet middle age. In comparison, the entire history of human civilization, the building of cities, the writing of stories, the shaping of nations has been only the briefest flicker. This is why we describe the life of a star as serene. Its quietness is not silence in the sense of stillness. Inside, there is motion, pressure, energy, but it is a balanced kind of motion, one that does not demand our attention with noise or sudden changes. Instead, it moves forward in a rhythm so slow and steady that, from our human vantage point, it feels almost timeless. If you looked at the sun yesterday, and you looked again today, you would see no difference. You could look again tomorrow, or 1,000 tomorrows from now, and it would still shine in the same way, unfaltering, unhurried. That is the essence of stellar serenity, an almost meditative persistence. It is easy to think of the universe as violent because we notice the rare moments of drama. A supernova can light up an entire galaxy, and for the blink of a cosmic eye, it steals our attention. But those moments are the exception. The true nature of the cosmos, when you let yourself rest in it, is much gentler. Imagine lying beneath a night sky in the desert or on a quiet field in the Midwest, looking up at the countless stars. They do not pulse like a heartbeat. They do not shout for recognition. They simply shine. And in that quiet shining, they remind us that life on the grandest scale is not always about sudden bursts of activity. Sometimes it is about calm endurance. What makes this quiet even more profound is that stars are not empty things. They are spheres of plasma, unimaginably hot, sustained by nuclear fusion at their cores. Fusion is an extraordinary process, one that could easily be described in terms of violence. Atoms are slammed together with such force that they merge into new atoms, releasing vast amounts of energy. Yet within the structure of a star, this energy is balanced so perfectly that it becomes steady light. Instead of explosions tearing it apart, the star holds itself in a kind of equilibrium. Gravity pulls inward with immense strength, trying to collapse the star into itself, while the energy of fusion pushes outward. The two forces cancel one another, creating stability. It is this balance that allows the star to live quietly for billions of years. From the outside, we see only the calm surface. We see only the quiet glow. There is a lesson in this that reaches beyond astronomy. In our daily lives, we often imagine strength as something loud, something that demands attention. But the life of a star shows us that strength can also be quiet. It can be steady and changing and enduring. A star does not need to announce its presence to be powerful. Its quiet light, visible across thousands of light years, speaks for itself. It does not hurry to complete its life. It does not waste itself in a rush. It simply continues, and in that continuation, it achieves something extraordinary. For us audience, this idea of stellar quietness resonates with the landscapes many people know. Imagine the calm of a summer night in the countryside, where the horizon is dark, and the only light comes from above. Or think of the wide open skies of the American West, where stars blanket the heavens so thickly, it feels like you could fall into them. These are the places where you feel the serenity of starlight most clearly. In those quiet moments, you can sense how the stars above you have been there for longer than any story told by people, longer than any nation has existed, longer even than the mountains and rivers around you have stood in their present form. Their lives stretch backward into times we can scarcely imagine, and they will continue long after we are gone. It is this endurance that creates comfort, because while so much in our world is fleeting, while our lives are filled with change, with beginnings and endings, the stars remind us that some things persist. Their light does not flicker when we face our troubles. Their glow does not fade because of the noise of our world. They remain steady, offering a kind of cosmic reassurance. To watch the quiet life of a star is to be reminded that time can move gently, that not everything needs to be rushed, and that true power is often exercised without haste. When you look up at the sky tonight, the light reaching your eyes may have left its star hundreds or thousands of years ago. In some cases, it may have traveled for millions of years, and yet it arrives, calmly, without announcement, as though it were always meant to be there, waiting for you to notice. That is the quiet life of a star, not just its existence across unimaginable stretches of time, but its quiet conversation with us across the vastness of space. The quiet life of a star is, in many ways, a reminder of how small we are, and yet how connected we are to the universe. The atoms in our bodies, the elements that make our bones and our blood, were forged in the hearts of stars that lived and died long before the sun was born. Their quiet persistence was not meaningless. It was the very process that created the possibility of life, the possibility of us. Every breath we take carries within it the memory of stellar lives lived long ago. And every night, when we look up, we are looking not just at lights in the sky, but at ancestors of a kind, cosmic ancestors that endured quietly, steadily, until their gift could reach us here. Every star you see in the night sky began its journey in a place of deep stillness, inside the quiet regions of space where clouds of gas and dust drift for millions of years. These clouds are called nebulae, and though they look faint and delicate from a distance, they are the wombs of stars. The process that leads from a dark, cold cloud to a shining sun is not quick, nor is it violent in the way we might imagine. Instead, it is gradual, patient, and deeply serene. It begins with nothing more than scattered atoms, floating quietly, waiting for gravity to weave them into something greater. If you could drift through one of these stellar nurseries, you would not hear any sound. There would be no rushing winds or sudden bursts. The gas is thin, more spread out than the air we breathe by a factor of billions, and yet over vast distances, gravity slowly gathers it together. At first, there is hardly any motion at all, only the faintest tug. Over thousands of years, those tugs become stronger, pulling atoms and dust grains closer, building clumps where once there was only emptiness. Imagine a winter snowfall settling on the ground, flake by flake, until a mound takes shape. The birth of a star begins in just that same gentle, persistent way. The material in these clouds is simple. Hydrogen atoms drift alongside tiny specks of cosmic dust, the ashes of older stars. Helium atoms float silently among them, reminders of the earliest moments after the universe itself began. These ingredients do not know their future. They simply exist, quiet and dispersed, until gravity insists that they come together. As the cloud contracts under its own weight, it grows denser. Particles bump into one another more often. Heat begins to build. What was once a frigid, empty darkness becomes a faint, warm glow, like the soft ember of a fire just beginning to spark. This stage of a star's life is called the protostar phase. To us, it is invisible to the naked eye. If you looked up into the sky, you would not see these infants glowing. They are hidden, wrapped in the veils of their parent clouds. But with special telescopes that can sense infrared light, astronomers can detect them, glowing faintly in the darkness. These are the stars before they are stars, the quiet beginnings of something that will one day shine brightly across the galaxy. They are delicate, unstable, still learning how to balance themselves against the weight of their own gravity. What makes this phase so serene is the timescale. From the human point of view, even the formation of a single star is slow beyond imagination. It can take millions of years for a protostar to gather enough material to compress enough matter at its core for the true spark of nuclear fusion to ignite. Imagine watching a candle that takes centuries to be lit, and only then begins to burn. That is the pace of the universe. It is not in a hurry. It is patient, deliberate, and unchanging in its rhythm. The clouds collapse slowly. The protostar grows gradually, and in time, the first flickers of starlight begin. As the protostar continues to form, it pulls in material from the surrounding cloud, creating swirling disks of gas and dust. These disks, circling around the growing star, are not wasted. They are the raw ingredients for planets, moons, and asteroids. Long before life exists, the seeds of solar systems are planted in these disks. And while the protostar itself is hidden, its presence is felt in the way the material dances around it, spiraling inward, warming, colliding, and beginning the slow process of shaping worlds. The quiet birth of a star is also the quiet birth of the stage on which future stories of life will play out. The environment of a stellar nursery is not solitary. Often, stars are born in clusters, siblings formed from the same great cloud. Imagine dozens, even hundreds, of protostars glowing faintly in the same region, each one a potential sun, each one on its own journey. They do not compete, but they share space, shaped together by the gravity of the cloud that birthed them. Over time, some may drift apart, carried into different regions of the galaxy, while others remain bound, circling one another as companions for billions of years. The quiet beginnings of stars are communal, like children growing up side by side, before taking different paths. From Earth, the most famous of these nurseries can be glimpsed in the night sky. The Orion Nebula, hanging beneath the belt of Orion, is one of them. To the naked eye, it looks like a faint smudge of light, but through a telescope it reveals itself as a vast, colorful cloud where new stars are being born right now. In that glowing mist, gravity is at work, shaping new lights that will shine for ages to come. And yet, if you could stand inside the nebula itself, you would not feel the drama. You would feel silence, stillness, a slow gathering. The brilliance we see from far away is only the surface. The true story is one of patience. In these birthplaces, time is the greatest sculptor. A star does not appear all at once, fully formed and blazing. It emerges through long stages, like a seed sprouting into a tree. First, there is only the invisible cloud. Then there is the quiet gathering of matter. Then comes the faint glow of the protostar. And finally, after millions of years, the moment arrives when the temperature and pressure at the core become high enough for fusion to begin. Hydrogen atoms merge, releasing light. For the first time, the star shines in its own right. But even this moment is not a sudden explosion. It is a gentle ignition, a flame that begins small and steady, destined to last for billions of years. What is remarkable is how ordinary the ingredients are. The same hydrogen and helium that fill most of the universe, atoms that float unnoticed through interstellar space, come together in just the right way, and from them emerges a sun. The process requires no special intervention, no extraordinary event. It happens because the laws of physics, acting slowly and patiently, bring order from emptiness. Out of stillness comes light. Out of cold comes warmth. Out of the dark nebulae of the galaxy come the stars that illuminate the night. For those of us here on Earth, thinking about the birthplace of stars connects us to a history far older than our own. The sun that warms our days was once a protostar inside a quiet cloud, hidden from view, gathering strength. Its disk of dust and gas gave rise to the earth itself, to the oceans and mountains, to every living thing that has ever walked or breathed here. All of it began in silence, in patience, in the calm of a nebula drifting through space. And the stars that dot our sky tonight are undergoing the same journey, each one quietly finding its place in the universe. Deep inside a forming star, hidden beneath layers of gas and dust, something extraordinary begins to happen. It is a process so powerful that it will sustain the star for billions of years. And yet, it begins quietly, almost imperceptibly, like a whisper in the stillness of space. This is the slow spark of fusion, the moment when hydrogen, the simplest and most abundant element in the universe, transforms into helium, releasing the light and warmth that define a star. To us, it is the difference between a cold cloud and a brilliant sun. To the universe, it is the heartbeat of creation itself. To understand this spark, we need to imagine the conditions at the very core of the protostar. Gravity, the patient hand that gathered the cloud together in the first place, continues to press inward. Every atom, every particle of gas, is pulled toward the center, squeezed tighter and tighter under the immense weight of the star's growing mass. As the gas compresses, its temperature rises. What begins as a cold, dark cloud becomes warmer, glowing faintly in infrared light. But gravity does not stop pressing. It pushes relentlessly, increasing the density and the heat at the center until the atoms can no longer remain as they are. At about 15 million degrees Celsius, the hydrogen atoms at the core reach a point where their natural resistance is overcome. Normally, the positive charges of atomic nuclei repel one another. They resist being forced together. But in this extreme heat, they move with such speed and force that they crash close enough for the strong nuclear force, the most powerful force in the universe, to bind them together. Two hydrogen nuclei, each just a proton on its own, fuse to form helium. In that instant, a tiny fraction of their mass is converted directly into energy. It is this transformation, this subtle alchemy at the heart of the star, that becomes its light. The beauty of fusion is its steadiness. It is not a sudden explosion, not a violent burst. It is a continuous, balanced process, occurring billions upon billions of times every second, yet producing energy in a way that feels calm when viewed from afar. That calmness is what allows a star to shine so reliably, night after night, for ages beyond our comprehension. When you see the sun rising in the morning sky, you're looking at the gentle result of countless hydrogen atoms fusing into helium. A slow spark that has been burning without interruption for billions of years. For us here on Earth, the scale of this process is hard to imagine. Every second, the sun converts around 600 million tons of hydrogen into helium. Out of this, about 4 million tons of matter are turned directly into pure energy, radiating outward as sunlight. 4 million tons every single second. And yet, despite this unimaginable outpouring of energy, the sun barely changes. It has enough fuel to continue this process for billions more years. To the human perspective, it feels infinite, unchanging, eternal. That is the power of fusion. It is not a single moment of brilliance, but a continuous flame that endures. The spark of fusion is also the beginning of balance. Up until this moment, gravity had been winning, pulling everything inward, threatening collapse. But once fusion begins, the tide changes. The energy released at the core pushes outward, creating pressure that counteracts gravity's pull. The star finds equilibrium. Gravity presses in, fusion pushes out, and the two forces reach a steady harmony. This balance is what allows the star to exist in peace, neither collapsing nor exploding, but simply shining. It is a delicate dance, yet it is stable enough to last for ages. In the quiet of this balance lies the serenity of a star's life. From the outside, we see only the steady light, unwavering and calm. We do not see the billions of collisions happening every instant at the atomic level, nor do we sense the immense forces at work. We see only the glow that filters gently through our atmosphere, warming our skin, lighting our days, nourishing the plants and cycles of life. The slow spark of fusion, though hidden deep inside, becomes the very source of comfort for all that depends on starlight. If you look at the night sky, you are seeing the evidence of fusion across the galaxy. Every star you notice, no matter how faint, is powered by the same process. The light that reaches your eyes tonight may have traveled for hundreds or thousands of years, crossing interstellar distances, but its origin was the fusion of hydrogen into helium. In that way, every star becomes a quiet reminder of the universality of nature. No matter where in the cosmos you look, the same gentle spark is burning. What makes this story even more remarkable is that fusion is not just the source of light, but the source of creation itself. In the beginning, the universe was simple. It was filled almost entirely with hydrogen and helium. All the heavier elements, the ones that make up our world, were born later in stars. Fusion, starting with hydrogen, creates not only helium but eventually, in the hearts of more massive stars, carbon, oxygen, and all the other building blocks of life. The slow spark at the core of a star becomes, over billions of years, the origin of the atoms in our bodies. When you breathe, when you think, when your heart beats, you are carrying within you the results of ancient fusion. For us audience, it helps to imagine this process not as an abstract scientific equation, but as something you have felt every day. The warmth of a summer afternoon, the glow on your face when you stand in the sunlight, the golden hues of dawn and dusk, these are direct gifts of fusion. They are the human experience of a process that began quietly in the heart of the sun. Without it, Earth would be cold, barren, silent. With it, we live in a world of color, warmth, and growth. The slow spark sustains not only the star, but everything that depends on its light. Fusion also carries a kind of reassurance. Because it is so steady, because it operates on timescales far beyond our own, it gives us stability. No matter what happens in our daily lives, no matter how much change or uncertainty fills our world, we can trust that the sun will rise tomorrow, just as it has for billions of years, powered by the same quiet process. This certainty is rare in a universe where so much is fleeting, and it is why starlight has always been a source of comfort. From ancient peoples who looked up in wonder to modern scientists who measure its details, we are all touched by the same spark. The slow spark of fusion is the heart of stellar life. It is what allows a star to shine, to endure, to give. It is not loud or sudden, but quiet and persistent, unfolding over ages. In its patience, it creates the conditions for galaxies to glow, for planets to form, for life to arise. When you look up at the stars, you are witnessing not just distant lights, but the ongoing work of fusion, the most fundamental act of creation in the universe. At the heart of every star, there exists a delicate balance, a quiet and unbroken dance between two of the most powerful forces in nature. On one side is gravity, relentless and unyielding, pulling inward with steady determination. On the other side is pressure, born from the energy of fusion deep within the core, pushing outward with equal persistence. This is not a fight, not a clash, but a harmony. It is a balance that allows a star to remain steady for billions of years, shining calmly across the darkness of space. Without this balance, stars would collapse under their own weight, or tear themselves apart in violent outbursts. With it, they achieve a graceful stillness, the kind of quiet endurance that defines their existence. Imagine this balance. Picture a massive sphere of hot plasma, held together by its own gravity. Gravity, by its very nature, is always inward. It does not rest. It does not release. It pulls every atom, every particle of gas, toward the center. Left unchecked, this force would cause the star to collapse in on itself, compressing into ever denser states. But inside the star's core, where fusion has ignited, a counterforce emerges. As hydrogen fuses into helium, immense amounts of energy are released. This energy pushes outward, not violently, but steadily, pressing against the pull of gravity. The two forces meet in balance, and the star settles into a state of quiet equilibrium. This equilibrium is called hydrostatic balance. And though the term sounds technical, the idea is simple. Two great forces, perfectly matched, creating stability. What makes this balance extraordinary is not just its existence, but its endurance. Once achieved, it can last for billions of years. Our sun, for example, has been in this balanced dance for nearly 5 billion years, and it will remain so for about 5 billion more. Day after day, century after century, the same forces act, the same balance holds, the same light shines. From our perspective on Earth, this balance is invisible. We do not see the inward pull of gravity or the outward push of fusion. We see only the result, a constant, unwavering glow. The sun rises each morning with the same brilliance it showed to our ancestors thousands of years ago. It warms the earth in a way that feels so consistent we often take it for granted. But behind that consistency lies a dynamic balance, maintained with precision, as though nature itself is conducting a slow, steady symphony. What makes this dance even more remarkable is that it does not require adjustment in the way we think of balance in human terms. When we balance something like a book on our hand or a tightrope underfoot, it requires constant correction, small movements to keep it steady. But a star, through the laws of physics, balances itself. If the star begins to compress slightly under gravity, the temperature at its core rises, increasing the rate of fusion, which pushes harder against collapse. If the star expands slightly, the core cools, slowing the rate of fusion, which weakens the outward push, allowing gravity to pull it back in. In this way, the star self-corrects, always returning to equilibrium. It is a natural feedback loop, elegant and unbroken, allowing stability without effort. This quiet self-regulation is one of the reasons stars can live such long and steady lives. Their balance is not fragile, but resilient. It adjusts automatically, maintaining harmony across unimaginable stretches of time. For us, this is a reminder of how systems in nature often find their own balance. Just as rivers carve valleys and winds shape dunes, stars find equilibrium not through force, but through the natural meeting of opposites. For people here in the United States, this idea of a balanced dance can feel familiar when compared to the rhythms of our own landscapes. Consider the steady rise and fall of the tides along the coasts of Maine or California, where the ocean ebbs and flows in harmony with the pull of the moon. Or imagine the Great Plains of Kansas or Nebraska, where the wind sweeps gently across fields of grass, bending and releasing in a rhythm that feels eternal. Balance is everywhere in nature, and the stars above us reflect that same principle on the largest of scales. When you look up at the night sky and see a star twinkling, you are witnessing the product of this balance. The light reaching your eyes has traveled for years, sometimes centuries, yet it is steady because of the harmony maintained within the star. Each photon of light was born from fusion, released from the outward pressure that balances gravity, and carried across space until it found you. The simplicity of that moment seeing a star carries within it the story of equilibrium on a cosmic scale. This balance also gives us a sense of trust. The sun will rise tomorrow because of chance, but because its balance holds. The same forces that have sustained it for billions of years will continue to do so, providing us with warmth, light, and stability. For ancient peoples, this reliability was sacred. They measured their time, their harvests, and their ceremonies by the steady rhythm of the sun and stars. Today, even with all our science and technology, we still rely on that same constancy, that same quiet dance between gravity and pressure. The balanced dance of a star is not static, it is dynamic, always in motion, always adjusting, but it is also calm. In its persistence, it shows us that strength does not always need to be loud or sudden. True strength can be steady, quiet, and enduring. The stars do not announce their balance, yet it is what allows them to shine so beautifully, after the slow beginnings in a cloud of gas and dust, and after the patient spark of fusion takes hold deep within the core. A star enters the longest and most peaceful part of its life. These are its middle years, a time of steady shining, a time of balance that can last billions upon billions of years. For most stars, this stage is called the main sequence, and it is during these years that a star lives most quietly. giving off light and warmth with the consistency that makes it seem eternal to those who watch from the outside. If the life of a star were told as a story, this would be the longest chapter, the one filled not with dramatic turns, but with steady, enduring calm. For our own sun, these middle years are where it finds itself now. At about 4.5 billion years old, the sun is middle-aged. It has been in this stable state since before the Earth was formed, and it will remain this way for another 5 billion years or more. Every second, it quietly fuses hydrogen into helium in its core, releasing just enough energy to push back against the pull of gravity. The balance is perfect, and the light is steady. To us, this light is so familiar, so constant, that we build our lives around it. We wake with it each morning, we measure our days by it, and we trust that it will rise again tomorrow without fail. The sun does not rush, does not falter. It continues its work with patience, one second after another, one day after another, across millions of years. The middle years of a star's life are not about change, but about persistence. The star remains much the same across vast stretches of time. Its size does not vary much, its brightness stays nearly constant, and its surface burns with the same familiar glow. From our human perspective, where even a single decade can bring enormous change, the steadiness feels almost impossible to imagine. But for the universe, this slow, steady shining is the norm. Stars spend the vast majority of their lives in this state. The brief drama of their birth, and the more turbulent years of their decline, are only small moments compared to the endless quiet of their middle age. This long period of stability is what makes life possible on worlds like Earth. Because the sun shines so steadily, the Earth has enjoyed billions of years of relatively stable conditions. Enough time for oceans to form, for life to arise, and for civilizations to grow. If the sun's light flickered wildly, if its heat rose and fell with sudden intensity, life could never have taken hold in the way it has. It is the quiet constancy of these middle years that provides the foundation for growth and change on the worlds that circle stars. Every forest, every ocean, every human moment has unfolded under the steady glow of a star in its calm middle life. In the grand sweep of the cosmos, these middle years are marked by patience. A star does not measure its time in days or centuries. It measures it in billions of years. Imagine the ancient redwoods of California, living thousands of years, and then stretch that timescale a million times over. That is the patience of a star in its middle years. From the first spark of fusion, it settles into a rhythm, and for ages beyond counting, it simply continues, shining in quiet persistence. It does not need to change. It does not seek to rush forward. It is content to remain as it is, balanced and bright. This chapter of a star's life also carries with it a sense of companionship. Many stars are not alone, but exist in clusters, or as part of galaxies filled with billions of others. During their middle years, these stars form the backbone of the galaxies themselves, the countless points of light that make up the Milky Way stretching overhead. When you look at the sky on a clear night, what you see is not the rare stars in their birth or their deaths, but the countless stars in their middle years, shining steadily, quietly, without end. The night sky is a tapestry of stellar middle age, a quilt of light woven by the quiet persistence of fusion. The middle years are also the time when stars give back most generously. Through their light and warmth, they shape the environments of their planets. They drive winds, rains, and seasons. They feed ecosystems through the energy of photosynthesis. They guide navigators across oceans and inspire poets to look upward in wonder. The star does not know the effect of its shining, but it shines anyway, and in doing so, it becomes the center of countless stories. Our own sun has been at the heart of human history from the beginning. It has been worshipped as a god, measured by calendars, and marked by festivals. And yet, beneath all that meaning, it simply continues its balanced shining, its quiet persistence across the ages. The stability of these years is so great that, in many ways, it hides the reality that change will eventually come. For now, the star has more than enough hydrogen in its core to sustain fusion. The balance holds firm. The outward pressure and the inward pull match each other perfectly, and the star shines steadily. But this balance, while long-lasting, not eternal, it will one day shift, leading to the later chapters of stellar life. Yet to dwell on that future while standing in the midst of the middle years is to miss their essence. For now, the star is steady. For now, it is content. For now, it shines quietly, without pause, without fear, without need for anything more. From Earth, we feel this steadiness in our bones, even if we do not always recognize it. Every sunrise is proof of the sun's quiet persistence. Every warm afternoon is a reminder of its constant energy. Every star you see in the night sky is living its own middle years, shining as it has for millions or billions of years, unchanged, steady, calm. Their light reaches you not as a cry of urgency, but as a whisper of endurance. They are there, they have been there, and they will remain there for longer than we can truly imagine. Even the longest lives eventually begin to change. For a star, those quiet middle years of steady shining stretch on for billions of years, but they are not infinite. Deep within its heart, the supply of hydrogen fuel that has burned so faithfully begins to thin. The change is subtle at first, so subtle that from the outside there is no sign. The star still shines with the same brightness, still gives the same warmth, still looks the same to the distant worlds that orbit it. But inside, in the quiet depths of its core, the balance begins to shift. This is the beginning of the whispers of aging, the gentle signs that even stars, so patient and enduring, move toward new stages of life. The story of this aging begins with fusion itself. During the long middle years, hydrogen atoms fuse together steadily to form helium. Over time, helium has been gathering at the center of the star, because helium, heavier than hydrogen, sinks inward. Slowly, the core fills with helium ash. The hydrogen that fueled the star's shining becomes less abundant. Eventually, there comes a point when the star can no longer sustain fusion in its core as it once did. The steady engine that kept gravity and pressure in perfect balance falters. Gravity, which never rests, begins to press inward once more, as if reminding the star that nothing lasts unchanged forever. But this inward pull does not end the story. Instead, it leads to transformation. As the core contracts under the weight of its own gravity, it heats up again, reaching new temperatures that can ignite hydrogen in a shell round the helium center. This new layer of fusion reignites the outward push, and the balance is re-established, though in a different form. On the outside, the star responds to this change by swelling. Its outer layers expand, and its surface cools. What was once a steady, yellow-white star becomes larger, cooler, and redder. It enters its next phase of life, the red giant. This transformation is one of the most remarkable in nature. A star that once seemed so constant and unchanging grows to enormous size. If our sun followed this path, as it will in about 5 billion years, it would expand outward to engulf the orbits of Mercury and Venus, and possibly even the Earth. Its surface would become cooler, glowing a deep red instead of the steady golden light we know today. The change would be vast, dramatic, and yet from the star's perspective, it would still be a process that unfolds slowly, across millions of years. The whispers of aging in a star are not only about expansion, they are also about new kinds of fusion. For more massive stars, the contraction of the core can ignite not only hydrogen shells, but eventually helium itself. Helium atoms, under enough pressure and heat, fuse into carbon and oxygen. For stars even more massive, fusion can continue further, creating elements like neon, magnesium, silicon, and eventually, iron. Each new stage is more fleeting than the last, but each one is a continuation of the quiet story that began in a cloud of gas and dust. The aging of a star is, in its own way, still a story of patience. Though the signs become more visible, more dramatic, more undeniable. To imagine a red giant in the night sky is to imagine a presence that is both familiar and transformed. Stars like Betelgeuse in the constellation Orion are examples of aging giants. When you see Betelgeuse glowing with a reddish hue, you are looking at a star nearing the later stages of its life, swollen and cooler on its surface, yet burning with complex processes within. Its light is softer, warmer, tinged with the signs of age, but it is still beautiful. These aging stars are reminders that even change can have its own serenity. They are not explosions, not yet, but expansions, whispers of what is to come. For us on Earth, the whispers of stellar aging carry meaning beyond astronomy. They remind us that change is inevitable, even for the most enduring things in the universe. The sun that sustains us will not always look the same. Its middle years, as steady as they seem, are only a chapter in a longer story. Someday, it will expand into a red giant, reshaping the solar system itself. But that someday is far beyond the timescales of human life. For us, the sun will remain the same for every generation to come. Its whispers of aging are too slow, too distant, to cause fear. They are reminders not of fragility, but of the vastness of time. The aging of stars also connects directly to the creation of life's building blocks. In their cores, as they fuse heavier elements during these later stages, they are forging the carbon, oxygen, and nitrogen that form the basis of our bodies, our atmosphere, our world. The whispers of aging in a star are also the whispers of creation, the processes that will one day scatter these elements into space, seeding new clouds, new stars, new planets, and perhaps new lives. Aging, in the universe, is not only decline, it is also preparation for what comes next. If you look up at the night sky from the quiet places of the United States, perhaps the dark deserts of Arizona, the rolling plains of Montana, or the wide open skies of Texas, you may notice the colors of stars. Some shine bluish white, young and hot. Others glow yellow, steady in their middle years. And some appear reddish, cooler, older, beginning their expansion. Each one tells a different story of time. Each one whispers its stage of life. The aging stars, glowing red, are like ancient elders among the countless points of light, carrying within them the wisdom of billions of years. The whispers of aging are gentle, but they are also profound. They tell us that nothing, not even a star, escapes change. Yet they also tell us that change is not an ending, but a transformation. For a star, aging brings new beauty, new processes, new roles in the universe. It may no longer be the steady, youthful presence it once was, but it becomes something even grander, expanding, glowing, and preparing to give its final gifts to the cosmos. After the long, steady middle years and the gentle whispers of aging, every star eventually reaches a point where its life must draw to a close. The changes that begin deep in its core, the slow shift from hydrogen to helium and then to heavier elements, lead to a final chapter. This chapter is not the same for every star. Just as people live different lives depending on their size, their circumstances, their environments, stars too follow different paths based on how massive they are. But all of them, in their own way, find an ending, a final rest that marks the close of their journey. After the fiery beginnings of a star's life, when it bursts into shining existence from the collapse of a cloud, something remarkable happens. It settles. The star enters a long and steady chapter, a period astronomers call the main sequence. This is the quiet midlife of a star, where balance holds, and time stretches further than we can truly imagine. For our own sun, this stage has lasted already for billions of years, and it will continue for billions more. Imagine that, a life so steady, so enduring, that entire civilizations rise and fall without the star changing much at all. In this stage, the star is like a deep, calm breath held for eons. It shines because hydrogen in its core is quietly fusing into helium, a simple process repeating itself endlessly, producing the light and warmth that flow outward. This midlife is not dramatic. It is not violent. It is steady, patient, and unhurried. For a human being, single lifetime feels full of change, of seasons, of endings and beginnings. But for a star, these human spans are less than a heartbeat. The midlife of a star is like a long afternoon stretched across the entire history of Earth itself. During this time, the star keeps burning, keeps shining, keeps sustaining whatever worlds may orbit around it. Our sun is in this phase right now. And that is why Earth thrives. The warmth of the sun is stable. The light does not flicker or fade. The conditions of this calm midlife have given our planet the chance to grow oceans, life, forests, and people who look up at the very star, making it possible. Without this balance, there would be no steady climate, no chance for life to emerge and persist. The quiet midlife of a star is, in many ways, the quiet foundation of everything we know. The patience of this stage is staggering. A star does not hurry through it. It burns gently, steadily, as if it understands that life, whether microbial, plant, or human, needs constancy to flourish. This stage is the great gift stars give their worlds. The longcom.it is in this part of a star's life that the universe seems most generous. There is no rush to change, no hurry toward an end. Just light, just warmth, just a calm rhythm pulsing outward through space. This is the star's middle age, and it is also its most productive time, giving all it can in the simplest and most enduring way. And so, as you think of the stars above, remember that many of them are in this stage right now, quietly shining, quietly giving, quietly holding their place in the universe. Their light may seem ordinary, but it is not. It is the light of endurance, of patience, of balance, stretched across unimaginable time. It is the calm heartbeat of the cosmos, steady and soothing, as constant as the sky itself. For stars like our sun, not overly massive, but steady and middle-sized, this ending is quiet compared to the violent ends of their heavier cousins. When the sun has burned through its fuel and expanded into a red giant, it will eventually lose the battle to hold onto its outer layers. Those layers, no longer bound tightly by gravity, will drift outward into space. They will form a beautiful, glowing shell of gas called a planetary nebula. Despite the name, these shells have nothing to do with planets. They are the softly illuminated remains of a star's atmosphere, glowing gently as the light of the star's core passes through them. At the center of this glowing nebula, what remains of the star is something very small, very dense, and very bright. A white dwarf. This is the final form of a star like our sun. A white dwarf no longer burns with fusion. Its fuel is gone, and the great engine that sustained it for billions of years has gone silent. Yet it still shines, not with new fire, but with the fading heat left over from its long life. Imagine a coal in a dying fire, still glowing, still warm, but slowly cooling with time. That is a white dwarf, the ember of a once brilliant star. Over billions more years, it will cool and dim, until it becomes a black dwarf, a quiet, invisible remnant lost to the darkness of space. For stars much larger than the sun, however, the ending is far less gentle. These stars burn hotter, live faster, and die more violently. When fusion in their cores builds up to iron, the process reaches a halt. Iron cannot be fused to release energy, so the star's engine stops. Without fusion to push outward, gravity takes over completely. The core collapses in on itself in a fraction of a second, and the outer layers crash inward, only to rebound outward in a colossal explosion known as a supernova. A supernova is one of the most powerful events in the universe. In the brief moment of its explosion, a single star can outshine an entire galaxy. The light from such an event can travel across millions of light years, reaching us here on Earth as a sudden, brilliant flare in the night sky. Supernovae scatter the star's material into space at incredible speeds, enriching the surrounding cosmos with heavy elements: gold, uranium, iodine, and so many others. These elements, forged in the heart of the star and released in its death, become the raw materials for new stars, new planets, and eventually, life itself. What remains after such an explosion depends on the size of the original star. For some, the collapsed core becomes a neutron star, a tiny, incredibly dense object where matter is packed so tightly that a teaspoonful would weigh billions of tons. These neutron stars can spin rapidly, sending beams of radiation sweeping through space like cosmic lighthouses. For even larger stars, the collapse does not stop at a neutron star. Instead, the core continues inward until it forms a black hole, a region of space where gravity is so strong that not even light can escape. Black holes are the ultimate rest of the most massive stars, their matter and energy folded into a point of unimaginable density. From Earth, we can see the signs of these stellar endings in the night sky. The glowing clouds of the Crab Nebula, for example, are the remains of a supernova that was seen on Earth nearly 1,000 years ago. Ancient astronomers recorded the sudden appearance of a new star, brighter than all the others, which then slowly faded. What they were seeing was the final rest of a massive star, its explosion scattering light and matter across the cosmos. Today, telescopes reveal the intricate filaments of gas still glowing, a lasting monument to a star's final gift. The final rest of a star may seem like an ending, but in truth, it is a transformation. The gas and dust released into space become part of the interstellar medium, the raw material for the next generation of stars and planets. The heavy elements created in the star's core become the building blocks of rocks, oceans, and even living cells. Every atom of calcium in your bones, every atom of iron in your blood, every atom of oxygen you breathe, these were all created in the dying stages of stars. The final rest of one star is, in a very real sense, the beginning of countless other stories. When we look at the sky from quiet places in the United States, the wide, dark skies over the Grand Canyon, the endless horizon of the Great Plains, the deep night over the Appalachian Mountains, we are looking at stars at every stage of life. Some are in their youth, some in their middle years, some whispering of age, and some already long gone, their light still traveling across the darkness toward us. Even the stars that have already ended leave their mark, not only in the light we see, but in the very atoms that make us who we are. We are, as the famous saying goes, made of star stuff. The final rest of a star is not a sad thing, not when seen in the context of the cosmos. It is part of a cycle, a rhythm that has played out countless times across billions of years. Birth, steady life, gentle aging, and final rest all are part of the same quiet story. Stars do not fear their ending. They shine while they can, they give what they have, and when their time comes, they transform into something new. The universe does not mourn their passing. It celebrates their gifts, weaving their remnants into the fabric of galaxies, into the hearts of planets, into the breath of living beings. When the life of a star reaches its final rest, the story does not truly end. The legacy of a star extends far beyond the quiet ember of a white dwarf, the violent collapse of a neutron star, or the mysterious depths of a black hole. What a star leaves behind is not only the matter it forged, but also the light it shared, the stability it offered, and the pathways it opened for life. A star's legacy is written into galaxies, into planets, and even into the atoms that make up our own bodies. To understand the quiet life of a star, to understand that its influence echoes across time, long after its light has faded. For billions of years, a star serves as a steady beacon. During its middle years, it shines with quiet persistence, giving light and warmth to any planets that may orbit it. That steady radiance creates the conditions for life to exist. On Earth, our sun's constancy has allowed oceans to remain liquid, climates to stabilize, and ecosystems to evolve. Every tree, every blade of grass, every human being has grown under the steady glow of our star. Even before considering what happens after a star dies, its living legacy is immense. It provides the foundation for entire worlds, but the deeper legacy of stars is found in their deaths, because it is in dying that they give back the most to the universe. The elements that make life possible are forged in stellar cores and scattered during their final stages. Hydrogen and helium may have been born in the Big Bang, but the carbon in your cells, the oxygen in the air, the iron in your blood, all of these were created in stars. The calcium that strengthens your bones was fused in the heart of a star. The gold in rings and coins was made in the explosive death of massive stars. Every breath you take contains oxygen that once burned within a star. Without the legacy of stellar death, there would be no life, no Earth, no us. This recycling of matter is one of the most remarkable truths of the cosmos. Stars form from clouds of gas and dust, shine for billions of years, and then return their material to space, enriching the universe for the next generation of stars. Each cycle creates more complex elements, more diversity, more possibility. In this way, the legacy of one star becomes the seed of another. The nebulae that glow across the galaxy are nurseries of new stars, illuminated by the remnants of old ones. In every glowing cloud of gas, in every new star being born, there is the echo of countless stars that came before. Our sun, too, will one day leave such a legacy. When it becomes a red giant and then a white dwarf, its outer layers will drift into space. Those layers will carry carbon, nitrogen, and oxygen elements that could someday help form new planets, new oceans, and perhaps even new forms of life. Though the sun will no longer shine in the same way, its presence will continue through the materials it releases. In that sense, the sun's story will never fully end. Its legacy will ripple outward, woven into the fabric of the galaxy. Beyond matter, stars also leave behind a legacy of light. The photons released by a star during its life travel across space for thousands, even millions of years. Some of the starlight you see in the night sky tonight began its journey before human civilization even existed. The legacy of that light is not only scientific, it is deeply human. For as long as we have looked upward, we have used starlight to guide us, to inspire us, to give us a sense of our place in the universe. Sailors steered their ships by it. Farmers timed their seasons by it. Poets and storytellers wrote about it. Even today, starlight carries a sense of wonder that connects us to something larger than ourselves. The legacy of stars also lies in the way they shape galaxies. Stars are not scattered randomly. Their gravity pulls them into groups, into clusters, into the vast spiraling arms of galaxies. As stars form, live, and die, they stir and enrich these structures, giving galaxies their beauty and complexity. The Milky Way itself is a living tapestry of stellar legacies, with stars at every stage of life, from newborn blue giants to ancient red elders. When we look at the band of the Milky Way stretching across the sky, we are seeing the combined legacy of billions of stars, each one contributing to the whole. Perhaps the most personal part of a star's legacy is the fact that we are part of it. The very atoms of our bodies were born in stars. Every heartbeat, every thought, every dream is powered by matter that was once inside a star. We are not separate from the stars we admire in the sky, we are their children. The legacy of their quiet lives and their final rests is carried within us, in the chemistry of our blood, in the structure of our bones, in the spark of our existence. Carl Sagan once put it simply, we are made of star stuff. To know this is to feel deeply connected to the universe around us. Across the United States, from the deserts of New Mexico to the mountains of Colorado, from the wide plains of Kansas to the deep forests of Oregon, there are places where the night sky reveals its full splendor. In those skies, you can see the legacies of countless stars, young ones burning bright, old ones glowing red, and nebulae shimmering with the dust of those that have already gone. Every star you see has already shaped the universe in ways you cannot imagine. Their legacies are written not just in light, but in the very existence of everything around you. The quiet life of a star is not separate from us, it is our story as well. Every atom of your body has passed through the heart of a star. The stars are not only above you, but within you. Their beginnings, their middle years, their aging, and their final rest are all threads woven into the fabric of your own being. To lie beneath the night sky is to see your own history written across the heavens. As you close your eyes, remember that you are part of this great unfolding made of stardust, sustained by starlight, and connected forever to the quiet lives of the stars. The story of a star is not just the story of light in the sky, it is the story of us. Born from clouds, shining in balance, aging with quiet grace, and returning its elements back to the universe, a star's life is a reminder that all things move in cycles. The iron in bridges, the oxygen in our breath, the calcium in our bones, all are gifts from ancient stars that lived and died long before the sun. Tonight, as you close your eyes under the same sky that has watched over humanity since its beginning, Let the quiet life of a star remind you that endings are never truly endings. They are simply the beginnings of something else, waiting quietly to unfold. The quiet life of a star, when viewed as a whole, is a cycle of giving. It begins with material borrowed from the universe, shaped into a glowing body. It shines steadily, sharing light and warmth. It ages gracefully, expanding, cooling, and transforming. And in its final rest, it releases everything it has created, giving back to the cosmos in a way that ensures new stars, new planets, and new lives will follow. The legacy of a star is one of generosity, of the persistence, of transformation. It reminds us that even the greatest lives end, but in ending, they leave behind the seeds for beginnings yet to come. As we bring this journey to a close, let us pause to take in the vast, quiet arc of a star's life, from the stillness of a cloud of dust, stirred by gravity's patient hand, to the first fragile flicker of fusion, to the long and steady middle years that shine with constancy. It is a story of balance, of rhythm, of time, on a scale far greater than our own. We have followed the whispers of change, the slow aging that swells a star into something larger, redder, softer in its glow. We have seen how, in its final rest, a star can fade gently into a white dwarf, or collapse violently into a neutron star or black hole. And we have watched how, in dying, it gives back everything it has created: carbon, oxygen, iron, and more, returning its gifts to the cosmos, so that new stars and new worlds may be born. Every atom of carbon in your body was made inside a star. The oxygen you breathe, the calcium in your teeth, the iron that flows in your veins, they are all remnants of stellar lives, carried through time and space, until they found their way here. We are living proof of the cosmic cycle, living evidence that stars do not die in vain. Their legacies are carried forward in galaxies, in planets, in people. It is easy to imagine the night sky as something distant, as something beyond us. But when you lie back and look upward, you are not looking at strangers. You are looking at family. The stars are part of you, and you are part of them. Their quiet lives shaped your very existence. So as you drift tonight into rest, let this thought guide you. Endings are never really endings. Just as the star gives back its light, its warmth, its elements, so too does life itself move in cycles. Nothing is wasted. Nothing is lost. Everything becomes something new. The legacy of a star is not measured only in light years or billions of years. It is measured in the oceans that shimmer under the sun, in the air we breathe, in the iron coursing through our blood. It is written in the galaxies that spiral across the night sky, in the nebulae that glow with the dust of those that came before, in the living beings who look upward and wonder. We too are part of this quiet story. The stars are not distant strangers, but family, and their lives are the foundation of our own. And so, as you rest tonight beneath the steady light of our own star, or beneath the countless stars visible in the dark skies of this land, let their calm persistence guide you into sleep. Their quiet lives remind us that endurance is beauty, that change is natural, and that even endings are only the beginnings of something new. The universe is vast. The stars are patient. And their story is, in many ways, our own. A star's life stretches across billions of years, but it moves with patience, never rushing or forcing, always unfolding in its own time. There is something deeply comforting in that. It reminds us that life, too, is not about rushing forward, but about steady persistence, quiet endurance, and giving back what we can. Just as stars give their light, their warmth, and their elements, we too leave behind legacies in ways we may never fully see. Tonight, as the stars keep watch overhead, let their calm rhythm guide your own heartbeat, steady and restful, into the quiet of sleep.